Intro.
Moving on to the chapter 2, which is the lesson the solar radiation. So solar radiation, often called a solar resource or just sunlight, is a general term for the electromagnetic radiation emitted by the sun. Solar radiation can be captured and turned into useful forms of energy, such as heat and electricity, using a variety of technologies. Basic principles. Every location in the Earth receives sunlight at least part of the year. The amount of solar radiation that reaches any one spot on the Earth's surface varies according to geographic location, time of day, season, local landscape, local weather. In addition, sunlight is as essential to life in the sea as it is essential to life on land. Some fraction of the solar radiation penetrating the sea is absorbed by plants during photosynthesis, and this energy is used in the conversion of inorganic matter to organic compounds. Some wavelengths of light are absorbed by water molecules and are converted to heat, which established the temperature regime of the ocean. Also, light in the sea controls the maximum depth distribution of plants and some animals. Vision in animals is dependent on lights, and certain physiological rhythm, such as migration and breeding periods, may be set by periodic light changes. So in this image, you can basically understand the solar radiation activities around the Earth's surface. We can see the incoming solar radiation and the reflection, the absorption, and then the most heat that is absorbed and emitted by greenhouse gas molecules, further warming Earth. So because Earth is round, the sun strikes the surface at different angles ranging from 0 degrees or just above the horizon to 90 degrees or directly overhead. When the sun's rays are vertical, the Earth's surface gets all the energy possible. The more slanted the sun's rays are, the longer they travel through the atmosphere, becoming more scattered and diffuse. Because the Earth is round, the frigid polar regions never get a high sun, and because the tilted axis of rotation, these areas receive no sun at all during part of the year. Next topic is the radiation at the sea surface. So, biological oceanographers have tended to use a variety of units to measure solar radiation at the sea surface and to measure light intensity at depth in the sea. For that reason, two light units used for biological studies in the sea are the Einstein, or E, which measures photons, or 1 Einstein is a mole of photons, and the watt, which measures the energy of radiation. So in these three studies, the first study is which is the letter A. It is a solar radiation spectra before and after passage through the atmosphere, showing the zone of PAR, or the photosynthetically active radiation or visible light. Next studies is the percentage of light reflected from a calm surface as a function of sun angle. In the last study, it is the changes in overhead solar radiation received at the solar I mean the sea surface with the latitude and season in the northern hemisphere, or contour lines that represents latitude. Moving on, now in this part, the solar radiation coming from the sun to the outside of the Earth's atmosphere is fairly constant. About half of this energy is absorbed and scattered in the various layers of the atmosphere, so that the amount reaching the surface is about 50% that received at the top of the atmosphere. Some of this is reflected back into the atmosphere from the sea surface. So, the amount reflected depends on the sun angle and becomes very large below a sun angle of 5 degrees to the horizon. During the day, the actual amount of radiation reaching the surface at any point is thus a function of the sun angle, the length of the day, and the weather condition. The sun angle is determined by the time of year, time of day, and by latitude. Moving on to the next topic, the radiation in the sea. In comparison with the other liquids, water is relatively transparent to solar radiation, but much less so than air. Of the sunlight penetrating the sea surface, about 50% of composed of wavelengths longer than about 780 nanometer. The remaining 50% of radiation comprises the visible spectrum with wavelengths of between approximately 400 and 700 nanometer that penetrate deeper in the sea. These are of particular importance of animals with vision, and because they are also approximately the same wavelengths used by plants in photosynthesis. These wavelengths are often referred to as photosynthetically active radiation, or PAR, as light passes through water. It is both scattered and absorbed with different wavelengths of visible spectrum penetrating to different depths. Red light is quickly absorbed, with only about 1% still remaining at 10 meters in very clear seawater. Blue light penetrates deepest, with about 1% remaining at 150 meter in clear water. There is an exponential decrease of light intensity with depth, and an extension of coefficient K is calculated to express the attenuation of light. So in this image, if we look at this, we can see that this infrared radiation is quickly absorbed and converted to heat in the upper meters. From this figure, the extinction coefficient K is different from various wavelengths of light. It is about 0.035 meter for blue light, but about 0.140 meter for red light. However, if many particles are present in the water, the blue light is scattered more than the red, and this will affect the color spectrum of undersea light, resulting in a shift of most deeply penetrating wavelengths toward a green color. So moreover, the extinction of coefficient is also affected by the amount of colored dissolved organic material in seawater, and by the amount of chlorophyll contained in a living phytoplankton and in plant debris. Also, this graph represents the penetration of light of different wavelengths into clear oceanic water. The lines indicates the depths of penetration for 10% and 1% of the surface light levels rather. Next. 3 vertical ecological zones in the water column are defined by the relative penetration of light in the sea. The shallowest zone is called the euphotic zone, and it is defined as that region in which light is sufficient to support the growth and reproduction of plants. Here, there is sufficient light for plant production by photosynthesis to exceed the loss of material that takes place through plant respiration. So in this graph, the vertical ecological zones established by light penetration in the sea. Remember that the light intensity scale is logarithmic with depth, so the position of the vertical broken lines delimiting the three ecological light zones are approximate on. In the clearest ocean water of tropics, light, which is visually detectable by a deep sea fish, penetrate to more than 1,000 meters in turbid coastal waters. Scattering and absorption of light are increased by the presence of much silt and numerous phytoplankton, and the same amount of light may not reach 20 meters. The amount of light required for photosynthetic production to just balance respiration losses in plants is known as the compensation light intensity. The depth at which photosynthetic production is balanced by plant respiration is called the compensation depth, and it defines the lower boundary of the euphotic zone. Thus, the euphotic zone extends from the surface to depth of just a few meters in turbid inshore regions, to a maximum depth of about 150 meters in very clear tropical oceanic water. So below the euphotic zone is dimly light despotic zone, a region where fish and some invertebrates can see, but where light is too low for positive net photosynthesis. An example of this is loss of plant material through respiration exceeds plant production by photosynthesis over 24 hours. However, living phytoplankton which have sunk from the euphotic zone may be present here, and then the deepest and largest region in the open ocean is dark apoptic zone. These extend from below the despotic zone to the seafloor. Here, sunlight cannot be detected by any biological system. These vast regions do not support plant life and is spatially removed from the initial link in the marine food chain. That's all to my report. Thank you for listening.